Hello, good evening, good afternoon from Transkribus, and welcome to today's webinar about baseline models and about the advanced parameters for complex layouts. We'll first talk about the introduction of layout recognition, then move on to the advanced layout settings, and we'll also have a look at how we can train a baseline model. Who's here today? Today with me here is Sarah. You probably all know Sarah. She's also previously attended a lot of webinars and hosted a lot of workshops herself as part of the user success team and one of our Transkribus experts, as we call her. She knows a lot of things. It's quite difficult to know everything about Transkribus, but I think Sarah's quite close. And I'm Helena. I'm part of the comms team. I've also been part of a lot of the webinars, and I'm always trying to put out helpful content, helpful resources to help you make the best of how you can use Transkribus. Let's get into the introduction. So if you've been using Transkribus, you're probably working with historical documents and want to work with them, want to analyze them, and want to transcribe them. So Transkribus can help you with that by making a machine-readable version with the automatic transcription with the help of AI. And you can edit the machine-readable version, you can correct it, you can also add metadata, and of course you can export or share the data as well. How does that work? Transkribus uses AI model, either existing custom AI models, or existing or custom AI models that convert your printed or handwritten text into digital text that is machine-readable, and again, that you can edit and work with. So how does that work? You've probably worked with Transkribus before, so you know that first you have to upload your documents to Transkribus so that you can work with them. And after that, you use the recognition that Transkribus provides. What happens during the recognition is basically two steps. First, the layout recognition, and then the text recognition. To have a closer look at what is happening in the recognition is that we have three pillars for the layout. So that is basically what happens during the layout recognition is first that the baseline is recognized, and the baseline is the polyline that is running along the bottom of the handwritten text line. You can see that here in the image, it's the line with the white dots. That is the baseline. The second pillar is a text region. So that is the green shape that is encasing the text. And with the default layout analysis, those baselines are clustered into text regions based on their coordinates on the page. The third pillar is line polygons. Those line polygons encase all of the handwritten text in a line, as you can see here on the image as well. It's the light blue region that is enclosing one line of text. When running the training, the text recognition training, those polygons are computed by an algorithm starting from the baselines. And when the text recognition is happening, it is happening at this line polygon level. Now, what can happen sometimes is that the layout isn't properly recognized. And today we'll have a look at what can happen in that case and how we can fix it or how we can improve those improperly recognized layouts. So what affects the quality of the final recognition is, again, one of these three pillars. So for example, inaccurate baselines. For example, here, what you can see is that the baselines are incorrectly recognized and there are way too few of the baselines recognized. This can mean that, of course, then in the end of the text transcription, that text is missing or that the text is incorrectly recognized, not all is recognized, and you have to start over or edit it as well. Then what can also affect the final text recognition are inaccurate text regions. This can affect it in two ways. One way is that the reading order of the lines is wrong, so they're basically mixed up, or that there are too few or too many text regions and they're incorrectly recognized. This can again affect the text in the sense that text that should have been recognized is not recognized. And the third way that it can affect the final recognition is by inaccurate polygons. So even if the baselines are correctly recognized, the model cannot transcribe the text properly. As mentioned previously, the text recognition is happening in this step, and this affects it in the following way. If you look at the image that we have here in the bottom, you can see that the text and the baseline below the text is correctly placed, but that the polygon is way larger and also encloses the musical annotation. So what this means is that during the text recognition, Transkribus doesn't only look at the baseline, but also at the symbols of the musical annotation and also tries to recognize those, even though it isn't text. So this can affect the recognition in the sense that there's additional letters maybe or something missing. It's incorrectly recognized because it's trying to recognize more than is actually there. So as it says there, the line polygons do not compromise most of the body of the letters, but can also compromise other elements on the page. Today, we will look at the inaccurate baselines and how to fix that and how to improve text recognition when the quality of the baselines is affected. The second and third points that can happen with inaccurate text regions and inaccurate polygons, we already have a solution with that with trainable field models or trainable table models. We have some previous webinars on that you can have a look at on how to train those field models and work with them. So we'll hope that those will be a helpful resource in those cases. But today we will focus on baselines, the advanced settings, and how we can train on baseline model. I will now hand over to Sarah, and she will go ahead and explain it further to you.
Thank you very much, Helena. I'm going to share my screen. Here we are. You should now see my screen. And we are going to talk about how to modify, which settings to modify in the case of inaccurate baselines. Here we have the worst case that you can find a newspaper. And if you just run the text recognition on a page like this, you will easily find out that Transkribus in some cases doesn't perform that well. And in this case, the solution is to run the layout recognition as a separate step. And then after the layout recognition is correct, run the text recognition. You need to pay attention to some settings that you can set to easily improve the quality of embedded recognition. So today we will look at which solution we can use inside of Transkribus to improve our layout recognition when the baselines are inaccurate, instead of manually correcting the baselines. The first solution is to try use a different baseline public model. The second is to modify the advanced settings, and the third is to train your own baseline model. When you run the layout recognition, even if you run it together with the text recognition, you are using a baseline model. So there is a model trained on the baselines that tells Transkribus how to recognize the baselines on your page. There are a few public models. The one used by default by Transkribus is the mixed line orientation model. So this is the one used when you start a text recognition with a model. But there are also other public models available. Here I have listed the one trained by us and the most popular ones, but there are also other baseline models trained by users and models that users decided to make public. I choose these three because these are the most commonly used and the most effective. Which baseline model you should choose in the case that the default layout recognition doesn't work well. It's most a trial and error process, so there isn't a fixed answer to this question. There isn't a correct answer. So if you go to the description of these models, you will see that the main difference between the mixed line orientation and the horizontal line orientation is the ground truth on which those models have been trained. The mixed line orientation has been trained on lines in all directions, so with different angles, while the horizontal line orientation has been trained only on lines that are horizontal or vertical. So I know that The name could be a bit misleading, but in reality, this model, horizontal line orientation, is good if you have horizontal and vertical lines, just lines in these two directions. While if you have also lines with different angles, I would use the mixed line orientation model. And then we have also the universal lines model, which was trained on a bigger data set, but it's not, it doesn't outperform the mixed line orientation. So it really depends on your material, and you need to test it to see which is the best one for your documents. And we will look at some example later so I can show you the difference. This is the first step that you can do, try to use a different baseline model. The second solution that you can use in combination with a specific baseline model is to modify the advanced settings. So when you launch the layout recognition, there is an option where you can change the advanced settings and modify them really improves the recognition. What I'm going to explain now, it's a bit technical, but you can review it in the slides or everything is also detailed in our help center, so you can also read it there. The first element that you can define is if you want to generate new text regions or if you want to keep the existing text regions. Usually, if you are starting the recognition for the first time on your page, you want to generate new text regions. You need to select the option keep existing text regions only when you're working when you have already drawn automatically or manually some text regions on your page. So in the case, if you have already used a field or a table model to recognize fields and tables, you need to select this option, keep existing text regions. Otherwise, if you don't do it, Transkrib, the new layout recognition will overwrite your existing text regions. Or you can also choose this option if you have manually drawn the text regions. Then we have the text region method, and this is used to tell Transkribus how you want the lines to be clustered into text regions. As Helene told us before, we use a bottom-up approach in Transkribus. So first, the baselines are detected, and after that, the baselines are clustered into text regions. Here you can decide how you want the baselines to be clustered. There is the general algorithm that clusters the lines from left to right and from top to bottom. And then we have the custom algorithm, which is a narrative clustering based on the leftmost point of each line. Usually the general thing is the better one, but you can also try the custom one. And then, in case you select the general text region method, you can also define if your baselines are only horizontal baselines or if they're mixed. And if you define also this element, so in the case of both horizontal and vertical lines, if you select a mix, this will improve the baseline clustering into text regions. So this first part is related to text regions and how the baselines are clustered into them. And then we have this option here, which is called image scaling. You can decide if you want to upscale your images or downscale them. Our advice is to first try with the default option. If you see that your layout recognition detects no or a few lines, it is very likely that there is a problem with the image scaling. So you can try to upscale or downscale your image. Usually upscale works very well when you have images with a lot of lines. In the case of newspapers, there are many lines and very tiny lines, and upscaling newspaper images is usually the trick to get better results. Then we have some option related to the baselines. And here you can set some parameters on how you want your baselines to be detected. The first option is the minimal baseline length. So here you can decide the minimum length of your baselines in pixels. The medium is 25, then we have low, which is 10 pixels, and high, or you can also manually edit this value. If it's set to medium to 25, it means that baselines that are shorter than 25 pixels won't be detected. Those baselines are discarded by Transkribus and you won't see them. This is to avoid noise on your page and also very small lines that maybe are just a stain on the page or the ink that is seen through from the other page. Yeah, it's to avoid that those wrong lines are detected as correct ones. Our advice is to set this value to low, especially if you're working with tables, because in tables there are the ditto signs or numbers with only 1 or 2 digits, so the baselines are very short. Baselines could be very short in tables, and usually decreasing the minimum baseline length to 10 to low, make sure that you are detecting everything on the page. Then you can select the baseline accuracy threshold. Is how accurate the transcription, the baseline recognition should be. It's a bit difficult to understand and maybe also a bit counterintuitive, but based on our test, setting the baseline accuracy threshold to medium or low gives the better results. So if you see that only a few lines have been detected, you can try to decrease the baseline accuracy threshold and set it to low, and this will increase the number of lines detected. Then we have this option, use train separators. By default, it's set to no, or you can select and decide if you want to set it to sometimes or yes. And when you increase this value, it means that nearby baselines tend to be merged. So if it's set to no, it means that usually the baselines are not merged, close baselines are not merged. If you set it to sometimes or oh no, sorry, it's the other way around. So if you see that baselines that shouldn't be merged are merged together, you need to increase to set the train separator to sometimes or no, or yes, sorry. And then we have also this value, maximum distance for merging baseline. It's related to the previous one. So if it's set to low, it means that only the closest lines are merged together. If it's set to high, it means that even baselines that are very distant one from each other, but they are on the same line, are merged together. And then we have the last settings. This one, split lines on region border. You can select this feature only if you are working with existing text regions. And if this feature is selected, the lines strictly obey to the region border. It means that the lines are cut where the region border is, and this is useful in the case of tables, because in tables the lines can be very close to each other, but in reality they belong to different cells. So if you flag this option, it will help you to have one line for each cell. And when this option is selected, you can also increase or decrease the line overlap fraction. There is you can define if you want that your line slightly overlaps the region border. It could be, especially in tables, that the line is slightly, the text is slightly over the border of the cell. And with increasing this line overlap fraction, there is a certain the line can go a bit over the border before being detected as a different line.
And there are, sorry to interrupt, there are a few questions in the chat, and maybe we can just have a look at them quickly. So the first one was regarding using the models. So the question was if using the horizontal line model instead of the mixed line model might help against the baseline diving into the next baseline when the handwritten text lines are not 100% straight. So the reference was, for example, the image of the newspaper that we had. Would that help, or would you recommend working with the advanced settings in that case?
Sorry. In this case here, I think here would help more using the advanced settings and upscaling mainly in this case.
Another question was regarding the minimum length that was recognized so that the model can recognize words that, for example, are only 2 letters. And there are only 2 letters, but yes, maybe you can have a look at the chat.
Okay, here it really depends on the resolution of your page. So you needed to test if in the case of newspaper, for example, I like to set the baseline length too high because it's very unlikely that I will get small lines. If you have very small lines on dot and very small line of only 2 letters, I will try to set it to low. Or if you still see that small lines aren't detected, I would manually set it to 5 pixels. But it's more, you need to test on your documents. Yeah. And to avoid adding small lines like stains, you could try to work with the accuracy threshold. Like you could try to decrease the baseline length, but also increase the accuracy threshold. So you should be able to detect the small lines, but also to avoid recognizing wrong lines. Yeah.
And the last question for now was about the importance of the line polygon containing all parts of the letters and how big they have to be.
It depends on what you are transcribing. Usually the default settings are fine, also because the polygons are if you're not using a film models, train online polygons, the polygons are computed again when you run the text recognition. So I can show you here, for instance. So here I've launched this is a layout recognition, and the polygons are just a certain number of pixels above the baseline. When I launch the text recognition, the polygons are computed again. There is an algorithm that we call baseline to polygons that computes the polygons, and maybe I can show you it. Let me see if it's enough. Yeah, if it's faster, we can see it live. So now what Transkribus is doing is computing the polygons. So all polygons won't be considered anymore. They will be computed again to really follow the script. In the case that Helene showed before, sometimes there are problems with the polygons, so you need, but there are very rare cases like with music annotations, or if you have very big characters like in titles or printed titles that are very big. In those cases, you might want to train a film model to detect those polygons. And if you do it and you need to, when you run the text recognition, you can select this option here. You have to select this option, keep original line polygons. And when you select this option, the polygons aren't computed by Transkribus, but the polygons that you have added with the field model or that you have manually modified are computed, are used. But otherwise, usually the normal polygons are just fine. Okay. Yeah, I think we can go on. Maybe in the meantime, the recognition will be finished. And I want to show you a few examples. The first example is this one. So here we have both mainly vertical lines of text, and here I run the recognition with one of the English the text titan or the English elder, and this is what I got. So as you can see, the default layout recognition is not good. I just wanted to show you what I can achieve just by changing the layout model. So I go here under recognition, layout, and I'm selecting the horizontal line orientation because here I have mainly vertical lines and not lines in various directions. And I'm also changing here the text baseline orientation to mixed. And now I'm going to start the recognition. And you will see that just changing these two parameters, the quality of the layout recognition is much better, even if it won't be 100% perfect, but it's definitely a big improvement. So now most of the lines have been recognized, and it's definitely much more better than what we have seen before. Just changing the baseline model, for example. And then I have also another example to show you. Here we have a page with some see-through ink. So this is not that clear because there is you can see the text from the other page, from the verso, and go here. Now I want to show you the difference, what we can achieve if we change the accuracy threshold. So I am going to select the mixed line orientation, with my opinion is the best one that we have. And I'm going to select the baseline accuracy threshold to low. If you want, you can also modify it here. I don't want to do it now, but you can also enter manually the value. And here you have all the information, like which is the range that you, in the threshold, for instance, is a range between 0 and 255. And we are going to start recognition. And you will see that because the accuracy threshold is set to low, a lot of lines that are not real lines will be detected. I already did the test before, so I can say this for this reason. But yeah, you can see there is also a bit of noise in the background. And if we set it to high, the recognition should be improved. I mean, maybe we cannot see that very well here. And this is something that you can test yourself. And in this case, what I would also do is probably to increase the minimum, the distance between the lines, to make it sure that those lines are merged together. Let me check a test I did before. Yeah, using another model. Yes, this was in this case, I used the universal line model, and this was with the accuracy threshold set to low. And you can see it also detects other elements on the page, like stains or the ink from the other page. And when the accuracy threshold was set to high, those elements haven't been detected. The recognition is far from perfect. Also, when it's set to high, probably here we also need to play with the other settings, but you can see the difference. And the most biggest example is this. Here you have this is the text recognition with the default settings. And what I would do in this case, and we also have a page on specifically for newspapers in our help center. I will select the mixed line orientation model. I want to upscale the image, set the baseline length to high, the baseline accuracy threshold to high, and the maximum distance for merging baselines to low. Because in this case, the baselines are very close one to each other, and I don't want that they are recognized just as one big line, because in reality they belong to different columns. So we can start the recognition.
And there are again questions in the chat. Maybe we can have a look at that while we wait for the recognition.
Yes, regarding advanced settings, why can't we use the setting text baseline orientation when text region method is set to custom? Yeah, because the algorithm, how it has been implemented, because of how it has been implemented mainly, because of the algorithm that are in the backend, you can only define the number of regions. So when you go here, so if it's set to general, you can also define the text baseline orientation. If it's set to custom, it's not possible anymore because this hasn't been implemented and there are two different algorithms behind it. Okay. Yeah, I haven't explained this, but if it's set to custom, you can decide how many text regions you want. I find it helpful if you know that there should only be one text region on your page. I prefer not to leave it to general, but set it to custom and say, okay, I just want one text region, because in this way you're sure that there will be only one text region per page. So I tend to use it in this way, just with the one option. And yeah, as you can see here, the recognition now is much more better, and almost all the lines have been recognized. The problem that is still present here is that those lines have been recognized just as one big text region. So the reading order of the lines will probably a bit problematic because the line will jump from one column to the other. The correct approach in the case of newspapers would be first to run the field recognition to identify all the text regions. In this case, we have a text region. We also have the text heading and the paragraph. And afterwards, you run the text recognition with the settings that we explained before, just remembering to select the keep existing text regions, because we want to keep the text regions we have recognized with the field model. And just to show you here, and I also want to select this option, split lines on region border. And now we're run, but the result will be similar to the previous page. What to do? In the meantime, we can move to the last solution. What to do in the case you cannot find a good approach, either with changing the baseline model or with the advanced settings. In this case, the solution that you have is to train a custom baseline model. So here I have an example, but you could also use a custom baseline model in the case you have a mix of horizontal and vertical lines. So in this case, for example, I have this index card, and as you can see, there are some problems because here not the entire line has been detected. The detour sign hasn't been found by the baseline model, these two lines this should be one line, but this has been detected as two different lines. And the model is also finding other elements of text, like this is the name of the printer of the index card probably, that I don't want to have because it's just noise in my recognition, because if I recognize this text, I will also have it in my transcription. What I want in the end as my output is data. So I want to have one line for each entry. I don't want to have the printer name here. I don't want to have this name here because I already have it at the beginning of the index card. And this is just an example. And I would like to train a baseline model specific for this type of documents. Baseline models are trained to find and follow lines of text in a document, help it to correctly align and recognize text. So instead of manually correcting the baselines, because the public baseline models aren't good enough, you can train your own baseline model. What is important to remember is that there should be a continuity in your documents. So the documents your documents should be similar one to the other. To train your model, you need first to create your ground truth, so the pages on which the model will be trained. And you can correct existing baselines or manually draw the baselines. Then you can save them as ground truth. And after that, you can start the training. We recommend a minimum of 50 pages of training data, at least to start training your model, because if you train it with a lower amount of pages, it's harder, you will get good results. The approach to create your ground truth, you can draw all the baselines manually or correct the automatic layout recognition. There isn't any difference in which approach you decide to take. Choose the one that it's less time consuming. As I've shown you before, you can draw the baselines only for the parts that you are interested in transcribing, but you also need to keep in mind that the baseline model is just looking at the layout. So it's not reading the content of your text. For example, in the case before, if the printer name appears always at the bottom of the first index card, the model can learn to avoid recognizing it. But if sometimes it appears at the bottom, sometimes at the top, sometimes in the middle of the page or in the left margin, and other times there is useful information, the model won't know what is written there. So it's just looking at the position of the lines on the page. And you need to keep it in mind when training the baseline model, because you need to know that it's not reading the text, but just looking at the position of the lines on the page. And when you run the text a baseline model, the text is not necessary. So what you need to do is just correct the baselines, and you don't need to correct the polygons, and you don't need to correct or transcribe the text. When you have your 50 pages of ground truth, you can go to train your baseline model. The first thing to do is to select the training data, which are the pages that the model will be trained on. It's very similar to the text recognition models. Then you can select the pages, the validation data, which are the pages not used for training the model, but for testing its accuracy during training. You can decide if you want to manually or automatically select the validation data. We recommend selecting the validation data automatically and assign 10% of your ground truth to the validation data. And in the end, you are asked to add some information about your model, like the name and the description, and then you can start the training. The training could take some hours or some weeks. It really depends on one side on the number of pages of your model, the number of pages in your training data, and also the traffic of our servers. But you can always check the status of your training in the jobs list within Transkribus. After the training, you can apply your custom and baseline model to your documents. It's as I showed you before with the public models, you can just go to your private models and select your private baseline model. The quality of a baseline model is indicated by this value. It's called loss on validation data, and it's the equivalent of the Carta error rate. So it indicates how well the model performs on the validation data. So how many pixels have been detected correctly and have been detected correctly as baseline. And a good value is below 10%. For going to the conclusion, I just want to show you two examples. So yeah, this is the one that I showed you before. To train a model, a baseline model on pages like this, what I need to do is to create my ground truth and extend the baselines to include also the data sign, merge those baselines together, and in the end have to make it appear as I want my final model to recognize it. And this is an example, and yeah, for example, you can, if you don't want to have this number here because you are not interested and it's just a noise that you will have in your transcription, you can exclude it. What is important is that you can exclude it if it appears always in the same position. For example, you cannot say we are here, for instance, no, I don't want to have this line recognized because I'm not interested in any data after 40. This is not something that this is relative to the content of the transcription and not to the layout. So you need to ask the model to recognize all the lines that are on the page, except those that are in a specific position, like this number, and the baseline model can learn not to recognize this number if it always appears in this position. And another example could be, yeah, here, this is a page with a mix of horizontal and vertical lines. At the moment, we don't have a baseline model that can deal with such a complex layout. So you would need to create your ground truth, something like this with all the lines, and do it for at least 50 pages, making sure that there are enough pages with vertical lines. So what is important is that not all the pages should have vertical lines, but a good amount of them should have vertical lines, and there should be a good range of samples for the model to learn, and then you can train your model over it. Yeah, do we have any other question, or shall we go to the conclusion?
Yes, I think there is one message that we accidentally overlooked. It was about a model that consistently draws the baselines too short at the end and the beginning of the lines, and if we have tips on how to remediate this.
It depends if a custom model or not. Yeah, you could try to. Yeah, I think the best solution could be to train a custom model, and to make sure when you train it that sorry, I'll have to go to this. Yeah, that the baseline is all the letters. Like here, it's a bit too short, so you should make this baseline a bit longer. If it happens with a public model, I think it depends on the material. What you could do is to try to, when you are here, yeah, I haven't seen the document, so it's a bit hard to say, but maybe you could try one of those settings, like to decrease the minimal baseline length and decrease the baseline accuracy threshold and increase the maximum distance for matching baselines. It could be that the end of the lines are detected as baselines, but then are disregarded because they are too short or something like that. In any case, even if the baselines are sometimes too shorter, you need also to look at the polygon and to see, maybe it could be that the baseline is a bit shorter, but the polygon is still correct, or the transcription is still correct. Like here, for example, the Y here is not completely included in the transcription, but still the recognition is correct. In this case, I wouldn't bother about modify this baseline. This polygon is not necessary. Also here, it's across these letters, but still the recognition is correct. The problem is when most of the letters are outside of the polygon.
Another question was about baselines and that they are identified correctly, but what could be the reason for the transcription stopping in the middle of the baseline? So that the baseline is the full line of text, but the transcription is stopping in the middle and not everything is recognized. So basically, if this is a baseline or an HDR model issue was the question.
It could be a polygon issue. So I would check the polygons, and that. And yeah, you see here, for instance, here we have this polygon. Okay, this is a good example. Probably this happens because it is at the top, and there is also this white border, which could be a bit disturbing for the model. You see the baseline is correct, but in reality, the transcription is starting there from hand nothing. And there is also some errors because it's a bit confused, and it's also transcribing something that is not here. Nothing is not, we don't have nothing twice. So the model is trying to transcribe everything that is inside of this line polygon, and this is why it's completely omitting this part, because this part is not included in the line polygon, so it's not seeing it at all. And I suspect that it also adds this part and nothing, because have used a super model, which has a very strong language component. So it's trying to fill the gaps by itself, and it's a sort of hallucination. So even if it's not reading anything here, it's trying to making sense, to give a sense to this line. But it could be that something similar is happening to you. So the polygon is not correct.
Okay, I think we need to slowly start wrapping up. We're already running over the meeting time a little bit. But maybe one last question about what can cause a baseline model to fail, and then we'll start wrapping up the webinar.
Yeah, it's very difficult to say. Yeah, it depends on the error message. It could be that there is not enough training material, or that the settings, that you have used some wrong settings, because when you train a baseline model, you can also define some advanced settings, and the best approach is to stick with the default ones. Or it could also just be that the machine on which the model was trained ran out of memory. If you fail to train, the training failed 3 or 4 times, you can drop us an email and we will have a look into it.
Okay, thank you, Sarah. That was most helpful. We'll quickly wrap up the webinar. Sorry for overrunning, and thank you everyone who stayed so far. Just to reiterate, Transkribus is here to make your work easier, to make your work with historical documents easier, quicker, and help you to actually work, edit, and transcribe your documents faster. Who's behind Transkribus? We are a cooperative of now almost over 200 members, and our mission is to unlock the paths and unlock every doc. And also we do that by investing every money that we make back into the product to improve Transkribus with new tools and new features. And we also do that by having different individual scholar plans, by having a subscription plan, We always will have our free plan for everyone that has all the Transkribus features that Transkribus is known for. So training models, using public AI models, also the baseline models, of course, and using the editor. For more professional use or research, we have our scholar and team and organization plans. You can have a look at our website of what those entail. They, for example, have access to the supermodels and more advanced and new AI tools that have and take more processing power. And we're constantly working on improving Transkribus and making new tools that make working with the historical documents even better and even easier. And our mission is to provide the best tools for unlocking historical data so that the experts can take care of what matters, and that is focusing on the historical documents. If you have some questions that are still open, feel free to have a look at our help center. We have a lot of resources there. There's also a link to our help desk where our colleagues Sonia and Johannes do their best to answer every ticket that comes in and answer all of your questions. We also have other webinars planned. For now, we have a product updates webinar on the 18th of February. There will also be future webinars, some more basic webinars, also in different languages. I've included the link here to our events page. You can always just check to see what webinars are planned, and we'll also share about them on our socials. We have some previous webinar recordings, for example, about training text recognition models, the field and table models that we mentioned, and we have a whole playlist on YouTube that you can check out for the previous webinar recordings. We're also recording this one, so for everyone who has or had to leave early or maybe has some questions later and wants to rewatch it and revisit the session, you can do so as well by just going to our webinar playlist on YouTube. I think the recording will probably be uploaded sometime next week. And I think that's it for today. Thank you so much for attending and also for staying a bit over the time. I hope that we could answer a lot of questions. I hope that the session was helpful. So thanks for attending. Hope to see you in the next webinar again. And I hope you enjoy your evening, the rest of the day, and I'll see you next time. Thank you and goodbye.